All right, so we have two examples to go through today. Both of them are inequalities that involve absolute value. And after we do those two examples, you're good to go and ready to show up in class. So you have very little preparation to do. So take a look at our first example. It is the absolute value of x plus 3 is greater than 5. And if I had directions to this problem, it would probably say something like, solve the inequality and graph your solution. So let's think about what we know about solving absolute value. Well, first, actually, let's talk about what we know about solving inequalities. Well, that's nice and easy. Everything about solving inequalities is the same as solving regular equations, except if we multiply or divide by a negative, we have to flip the sign. So that's the only thing that's been different about solving inequalities. Secondly, let's talk about absolute value. Whenever we solve something with absolute value, remember we can get two different answers. So for instance, an absolute value that needed to be 5, I could either get a 5 or a negative 5 on the inside, and I would still get an answer of positive 5, because absolute value always yields a positive, even if the number inside of it is negative. So just like with equalities, we're going to set ourselves up with two equations, number 1 and number 2. One is going to compare x plus 3 to positive 5, and one is going to compare x plus 3 to negative 5. Now normally if I was solving an equation, I would put an equal sign here, but we're not. So that's why I'm leaving it blank. Let's look at the sign that we have right now. It's a greater than sign. Just like before, when I had an exception to the rule, if I multiply or divide by a negative number, I have to flip the sign. The same sort of rule is going to apply here. If I keep my number the same, 5 and 5, I keep the sign the same. But if I change the positive negative sign of my answer, so instead of 5, I have negative 5, then I have to flip the sign. So here it stays the same because it's greater than 5. Over here we are less than negative 5. And if you're wondering why that happens, that's because right now I'm looking for values. Here's 0. Here's 5. I'm looking for values that are going to be greater than 5. That means 5, 6, 7, 8, 9, 10, or any of the numbers in between. Or I can be looking for negative 5. Well, actually, it's not going to be negative, but below negative 5. And any of the numbers below. Negative 6, negative 7, negative 8, negative 9, negative 10. So, like negative 10 pairs with positive 10, right, in an absolute value. Or negative 8 would pair with a positive 8 in absolute value. So, we're looking for numbers that are above 5 or below negative 5. That's why over here we have above or greater than 5 or below less than negative 5. So, there's a little, this is why we do that. I'm going to undo, undo, undo. Okay, let's go back to solving our two inequalities. So we have x plus 3 is greater than 5. To solve for x, I subtract 3 from both sides. That gives me x greater than 2, which is my first solution. And then I solve the next one, which is subtract 3 from both sides, and I get x less than negative 8. And I don't have to flip the sign because I have not multiplied or divided by negative. Now, how do I graph this solution? Essentially, I'm just going to graph both x greater than 2 and x less than negative 8 on the same graph. So here's 0, and 1, 2, 3, 4, 5, 6, 7, 8. There is negative 8. And so actually, I will graph open circle and below. And then up here I have 1, 2. So I've graphed this one. 1, 2. I want to do an open circle, x greater than 2. So it's 2 and above. And that is how we graph. Yeah, it looks a little bit funny, but it shows that if I plug in any number below -8, or if I plug in any number above +2 into my original equation, I will get an appropriate answer. I'll get something that's greater than 5. So that's example 1. Without switching the video, because we're basically just going to do the same thing, I want to show you a second example. It'll be the absolute value of x plus 3, but instead of greater than 5, it's going to be less than 5. So I'm going to delete all this, and instead of x plus 3 greater than 5, I have x plus 3 less than 5. How do we set this up? Well, we have possibility number 1 and possibility number 2. Our first is that x plus 3 could be less than 5. And our second is that x plus 3 could be greater than -5. So again, I have same 5 and 5. I've changed it, 5 and -5, and whenever I switch the sign, I also flip the greater than less than sign. And now I solve. Same as last time, so I won't talk you all the way through it because it'll be redundant. The only thing that's going to come out a little bit different here is the direction of the inequality. And that is going to affect our graph. So what happens here is I still have boundaries of 1, 3, 4, 5, 6, 7, there's -8 and 2. So those are our boundaries. But this time my solution set is -8 and above, and +2 and below. So see how these arrows are pointing at each other? What that means is that the solution set is any number between -8 and 2. So I'm going to just rewrite this up here in the top corner so you can see it more neatly. Let's put 0 here. Here's 2. Here's -8 down there. The solution set to this inequality is anything between -8 and 2. Looks a little different than the inequalities we're used to, but kind of makes sense. It means that any number that is on the number line between these two boundaries, if I plug it in over here, I should get a correct answer. And let's try it. Let's just choose, I don't know, we'll do -1 because that's within our range. If I plug -1 in for x, I get -1 plus 3, that's 2. The absolute value of 2 is 2. And yes, 2 is less than 5, so we are correct. That's a correct answer. And that, my friends, is all the new material. That's all we have to do. So we're still solving inequalities, we're still looking at absolute value, and now we're just putting them together. All the steps are pretty much the same, except that we get kind of these interesting line graphs that we hadn't seen before, but the rest of the rules hopefully will seem pretty familiar to you. So congratulations, that is the final lesson for Unit 1.